A rotation is also one of our rigid transformations. A rotation can feel a little bit trickier to do by hand without tracing paper. So a lot of times we'll trace over our figure with like wax paper, like see-through paper, and we'll actually physically rotate the figure. Unfortunately, we cannot do that. I don't know if I lost anything, so I'm just going to start over. Okay. Our last type of rigid transformation is a rotation. So a rotation is going to be turning. So that's our keyword here. We call it a turn. Our figure either clockwise, so the direction that a clock goes, or counterclockwise, so the opposite direction that the clock goes. And when we turn, we're physically turning this image either 1 turn, 2 turns, 3 turns, or 4 turns in that direction. And instead of calling it a certain number of turns, we use 90 degrees, which is 1 full turn, 180 degrees, which is 2, or 270, which is 3. Which makes sense because that's 1/4 of a way around a circle, 2/4 a way around a circle, 3/4 the way around the circle, and then we have our full circle, which is 360 degrees. So let's look at this using a little piece of paper. So I like to use tracing paper. Unfortunately, you can't have tracing paper on the EOG, but we can still use a piece of graph paper and just physically turn it to help us. So if I have this piece of graph paper, and what I'm gonna do with my piece of graph paper is I'm actually gonna just align it with my graph. So it doesn't have to be exact, and I'm not gonna number anything. I'm just gonna match this scale and you'll see why. What I'm going to do is I'm gonna draw my image on here. So this original figure, C, is at -1, 0. B is at -1, 3. And A is at -5. So 1, 2, 3, 4, 5, -5, 2. So what we would do if we had tracing paper is we would have just physically traced that image. This is just our way of doing that when we don't have tracing paper. So like for the EOG. So I have my image. I'm going to connect my dots. And now I can make my turns. This says rotate figure ABC 90 degrees, 180 degrees, and 270 degrees counterclockwise about the origin. About the origin just means that that's where I'm rotating around. That's all you'll be rotating around for these type of problems. So let's start with 90 degrees. So we're going counterclockwise. So a clock goes this way. We're going to go that way. And 90 degrees is equal to 1 turn. So what we're going to do is we're starting where our figure starts. We're going to put our pencil on the origin, and my paper is aligned perfectly straight up here. I'm going to turn it once. So I'm turning it 1 time so that my axes, see how that they're aligned here? I'm just turning it once. And that's giving me my new coordinates after 1 rotation, 90 degrees counterclockwise. So I'm going to place these new coordinate locations for this turn. So I know C is located. I can write it over here. I can also just keep the orientation like that and just sketch it real quick. So I know C is at 0, -1. So we're going to put C prime. I know B is at 1, 2, 3. So -3, -1. And A prime is at 1, 2, 1, 2, 3, 4, 5. So at -2, -5. So again, what would have happened here is we would have just had our tracing paper and it would have been a lot easier to see, but we can't do that for the EOG or for a test, so we just have to improvise. That is our one turn. So after 90 degrees counterclockwise, this is our new location. We're going to do the same thing for 180 degrees. So I'm going to go a little bit quicker for these because it's going to be the same thing. So the next was 180 degrees. So that's 2 turns. So 1, 2. This is my new location. So I need to plot these points. I'm going to name this C prime prime. I'm going to connect my dots. Then I can rotate once more. So this would be our 270 degree rotation counterclockwise. So 270 is 3 turns. So 1, 2, 3. I'm going to put my coordinates where they belong. So V is at 3, 1. So that's our B prime. Prime, C, prime, and then A is at 2, 5. We would connect our dots, and we have 3 different rotations. This one is the most confusing to look at algebraically. It's very nice to look at when you're just looking at it from afar, but algebraically, when you're doing 90 degrees versus 180 versus 270, you're flipping your X and your Y with each other. You're also flipping your signs. So I'm going to write that out quickly. It's something you can memorize, or you can just work it out, which is always my preference. But just quickly, one other thing to note is that you actually are creating, there are only 4 different rotations that you can really do. You know that 90 degrees counterclockwise is the same thing as 270 degrees clockwise. So first I'm going to just write which ones are the same. So 90 degrees counterclockwise is the same as 270 degrees clockwise. 180 degrees in either direction is equal. And then our 270 degrees counterclockwise is equal to 90 degrees clockwise. And then 360, you're just going back to your original location. What happens when you have a 90 degree counterclockwise or a 270 degree clockwise is you are looking at the rotation from here to here. So what happens to your coordinates is you can just look at what happens from A, which is at -5, 2, to A prime, which is at -2, negative 5. So what happens here, if we have coordinate x, comma, y, is they are switching spots. So x goes to where my y is and my y goes to where my x is. The x value keeps its sign, but y gets the opposite sign. So xy becomes negative yx. Again, if this seems super confusing, you do not have to use it. They just can give it to you in the algebraic form, which is unfortunately, just a lot of memorization of letters. So I'm gonna fill in the other ones real quick. So that's our algebraic. This part, I'm not gonna say it's not important. It would save a lot of time to have it memorized, but it's also something that, if you confuse something, you can't really, reason your way out of without drawing it out. So this is what's actually physically happening to the coordinates. You can see that A goes from being located, at negative 5, 2, to being located at negative 2, negative 5, to being located at 5, negative 2, to being located at 2, 5. So the magnitude, the size of the numbers physically do not change. You're only dealing with 2 and 5. What's changing is where it's located, X or Y, and then its sign. So that's our rotation.